All right, we're going to have a little review here. All right. All right, so in your engineering notebook, if you, or excuse me, in your, you don't need to open this, but you can, because you can look around, you can look on here, you can, but it should be a PDF of what I'm going to show you. Well, maybe if I can find my instructions. There it is. All right. And it talks about the engineering notebook. I'm going to be a little bit straight with you. It's pretty dull. Okay. But what I've been waiting for is for these to come in into your engineering notebook. And everybody has one, correct? Yep. All right. Awesome. So what this does, and it's a little bit dull if you go through this, but I'm going to make it very, very interesting. And when I did an internship at 3M, they had them not quite like that. They had them more like this. Okay? And this was an engineering notebook, and beginning of work, they'd come and they would get it out and they would give them that engineering notebook. Okay? And then they'd do all their calculations, all of the things. And they might have 5 of them, actually, because one for each project. Then when they were done for work, or if they had to go for lunch, they gave it to someone or they locked it up. That engineering notebook could not leave the company, could not leave their building. They had to talk to their boss if they were going to take it and take it across the street to another 3M building just down the road. It was a legal document because 3M's business success is on their patents. And so that's why it's a legal. Can't have earphones in. Okay? No. That just goes for everybody. Pretty much can't have earbuds during class. If you're working in inventor or that kind of stuff, of course you can. Can't have it here when I'm talking. Okay? Or when you're even doing any type of group work, do not have earbuds on. Okay? That's just good advice. But anyway, it's a legal document. And so therefore, they spend over, and I'm not exactly this, but almost $1 billion a year on patent infringement lawsuits around the world. And the reason why is they really thrive on invention and innovation. What are the difference between invention and innovation? Anybody know? Yes.
Innovation is like moving forward in technology.
Okay.
Like invention is just something you made.
All right. Good. The person that what would be a great example? Okay. The first person that ever wrapped leather around their feet invented a shoe. Okay? Since then, it's been an innovation. So, the first cell phone ever that had a big, long antenna and, or was connected to a bag, that was an invention. Okay? From there on, they were all innovations. And so most things are innovations, not inventions, right? An original idea, thought, invention, innovation, all right? What's the difference between a scientist and an engineer? Samson?
One does science stuff and one does something with building.
Yeah. I'll give you some of that. Anybody want to help Samson out, add a little more to that?
I find it, yeah.
What now?
Once I find it.
Yes.
So the scientist is finding why something is, and the engineer is like making something.
Okay. For a economic value. Discovery. Okay, does that make sense? Scientists are looking at our natural world and they're like, that's extremely interesting. I want to learn more. Engineer looks at it and goes, that is interesting. How can I make money on it? Okay? What can I do how can that improve human life? Okay? Yes, Anthony?
An engineer is a professional who designs products to work more efficiently, and a scientist is someone who studies to make new things.
Studies to make new things, discovers new things. Good, good. All right. So, engineering notebook. We'll see how this works. It's not a PowerPoint. All right. Don't have to write this down, but I want you to pay attention. Engineering notebook is a book in which an engineer will formally document in chronological order. What's chronological mean? Yes.
Like the same time that it went through.
Yes. Okay, if you're not working on this, all right, I want you, because otherwise I got people behind you, can't focus. I know you can though. All right, associate with a specific design project. We're going to do our first project that we really have in here. We'll do some small things like, I had doing your engineering notebook, the paper bridge and stuff like that. That'll have you to kind of train you to use it. But our first real project is probably going to be like an earbud holder. No, it's not. It's going to be a cookie cutter because it's getting close to Christmas. So you're going to go through the design process to create a cookie cutter. Okay? How you do that, we'll learn Inventor. We're going to, all that. And then we're going to 3D print that. Okay? So you're going to go through that process in your engineering notebook. Clear and detailed description of the design process. It's a legal document, folks. Okay, when we had, remember the just in case mention? Okay, that came in the school, okay? Not in this class, but it came from the school. And we had to, when he was going for a patent, I helped him go through the design process, show that it was his original idea, right? Prove the origin idea that led to the solution. How did this become your idea? Prove diligence in turning an idea into a solution. And, okay. Connor, can you take your hat off? Just notice that. All right. Now, this is what's in it. So you might write some of the things that you think are, okay? Discovering the problem. How did you come about this? This is a problem. Sketches with labels and descriptions. Brainstorming. Okay, so when you sit down and have a brainstorming session like we did for robotics, hey, anybody interested, be talking to me, okay? We got a meeting after school tonight. And if you can't make it, that doesn't mean, well, you're not in robotics, okay? Be talking to me if you're interested at all. All right, so, a little PSA right there. All right, the brainstorming. All things, we talked about that. calculations, all your mathematical calculations that are brought up, your daily thoughts and ideas. Okay? Pictures. Expert input. So if you would call somebody, get some information online, that would go in. All your test procedure, your work session, your meetings, digital technical drawings, your design modifications. It's extremely, extremely important that you show how this product became from the problem to the solution. The whole process. We did a class. We might do it again when we get enough to take it. It was called Engineering Design and Development. And what they had to do is go through using the design process, come up with a problem, and then find a solution. So what one group did was, I can't remember the number, but too many young kids died in their car seats because the parent, grandparent left them in there on a hot day. And what this was a car seat that these were filled with chemicals like you break, like the ice pack, and you hit it and it breaks open and the two chemicals join and they get cold. Okay, so that had this, it had a temperature gauge that could tell you the thermal, and it had they wrote code, and that would text you at a certain temperature, then would text 911 at a certain temperature, and it wouldn't tell you the baby's temperature. That was not accurate. It would just take the air temperature, okay? And it was also sensed, that the vehicle was in or something was in, so that like when you just first put your kid in a hot day, it's going to be hot, and it's not going to call 911. It's going to do it after the baby's been in it. And that's been, and all the working, okay, you know what they discovered? Engineering is a lot of writing. They said, I can't believe how much we have to write and prove that we're going from discovering the problem to the solution. Everything you do, think, relate to that specific design project needs to be in there. Hunter, I need your head up. All right. So you look here, you got a title page. That's what this right here. Table of contents, chronological order. All right. Best practices. Take a look at this. There's also, I'm not sure. Do you have best practices in here? No. This does not have a sample of best practices. All right. It is bound. Why is it important that it's bound? Because you could tell if something was ripped out. More importantly, you could tell if something was added. Okay? So that way, legally, you take this and you couldn't take this apart and add like 3 pages and say you invented the iPhone. Okay? And say, hey, it's my idea. Now you owe me millions of dollars. Okay? Signed, dated. Sometimes they even take pictures with a newspaper, that day's newspaper, and put it in towards the end. So then they have different people that can say, yeah, I signed that at this date. Okay. Do not leave blank pages. If they do, you just put a cross there and sign it. Okay. If you make a mistake, you do not erase. Should be in pen. Why do you think in pen?
Then you can't.
Can't erase it. Okay, I don't ask for that, just so you know, because I don't like to work in pen. And if I was an engineer, I would work in. All right, thank you, Joy. And so you can see they just cross out. Mistake. You make a math mistake. You don't erase it, because that was embarrassing. You just cross it out and you do the right. Okay. As you can see, you annotate your sketches. Annotate. That's what this is. These little arrows. Okay. It's dated, as I've already said probably 3 times. Then you get something from the computer. You get far enough to where that idea gets that in the computer. You need to print it out. Then you tape it in and you sign. And I'd rather have you actually sign right there. Okay? Now, do I expect you to do all this? I don't. Okay? I do expect you to understand this so that's and have an appreciation when you start looking at the new products that 3M comes out, the new types of iPhones, the new inventions. It's just not the product itself, but the process that went in. Okay? Nope. Why do you think they sign like this?
So it passes the picture in the book.
Right. And so that you can't then take this off and then slip in something else that's better. You know, your competitor came up with a better idea and you want to have that patent. Okay? As you can see, the calculations crossed out, the blank spots. Sign and dated each page. Come on, keep coming with me. We already talked about this. This is what we need from you. Be neat, be accurate, be legible, and be thorough. Okay? So write that down. Now. All right, good. We'll have some common mistakes that are made, are using loose leaf paper, putting a piece of paper in. If, let's say you were somewhere and you didn't have your engineering notebook and you came up with an idea and you sketched it out, you could still put that in there, tape it in, sign it, date it, have it in there, right? So that those kind of things can still happen. Now, how you use this is kind of up to you because this is a whole engineering notebook and you won't use all of it, right, for our ideas. I mean, unless you're extremely, extremely thorough. But, so you can also keep notes of your engineering notebook as well, okay? So what we did now we're going to go through the problem solving process. And I want that written in here. Another thing you can do is take the engineering design process. Let's see if it's still there. No, I don't want that. And put it in there, just tape it in there so you have it. But so here we go. This is what I wanted. So you were to do this, and some of you haven't because you weren't here on Monday. Some of you got partial, some of you are done. To me, it doesn't matter right now. During your lab time, I want you to complete this if you're not, right? This was the project we did with the sub, okay? You are to document your steps in your engineering design process, or in the notebook. First was to define the problem. Take out your engineering notebooks if you haven't done this. Some of you already have, okay? And you got a page number. You dated it, and you titled it, IED Instant Challenge Paper Bridge. Then, first step of the design process, define the problem, right? Span blocks with cardstock. Okay? And I would span the blocks as far as possible with cardstock. Using only cardstock, actually, I think would be a better definition of the problem. Okay, do you have that down? Because that's what I'm going to be asking from you. Jordan, you got this done? Okay, good. Now, those of you that have this done, make sure that you have this in your engineering notebook as well. Okay, the engineering design process. I'm not asking you to write all the constraints, but I do want you to, the best design is the furthest the blocks are apart. And I got told that somebody built one group 16 and a half outside block to outside. Whose group was that? How come I got a bunch of hands up? Were you tied?
They were
We
17.
were 17, like at the last second, and he really didn't write that down.
Oh, okay. 17? All right.
And then in last time, somebody got a 19-inch one.
Okay. They did. Okay, cool. Who did that? 19 inches?
Oh, yeah, that was me.
Okay, cool. Awesome. All right, so now we would look up prior attempts. I didn't have you do that, right? And now we've defined the problem. We've done due diligence. Now we're going to generate some concepts. Did he have you write 3 brainstormed ideas?
Yeah.
Okay, so you should have 3 different brainstormed ideas. If you weren't here on Monday, Friday, you can do that later. All right, then, after you get your 3 ideas, what do you need to do? What do you need to do after you get your ideas?
Test
Do you test all 3 of them?
the best.
The best one, okay? So we go to develop a solution. Okay? And after you develop your solution, typically I do have you re-sketch it in greater detail. Okay? Here I didn't because it's kind of, you only have the class period. And then construct and test a prototype. Hopefully you build it. Okay? Once you built it, you take a picture of it, evaluate the solution. We're not presenting it, but what you would have done differently. How would you have made this better if you had to do it again? And then it goes right back to the beginning. Okay, and we start over. Because the design process is never really done. Alyssa.
Once you take a picture, where do you turn it into?
Yeah, don't do the deep dive. Though you could actually, because I don't really have an assignment on that. No, let me put it. If you still have it, a picture of it. I'm not going to ask you to redo it. Okay. I do want to see your engineering notebooks look like. Whoops. Somewhat like this, but this is what I want. I want you're defining the problem, you're generating concepts, and then you picked one, you circled it, you developed a solution. So I want to see 3 steps. Then building the prototype, you would put in there somewhere what you did. Take a picture. I need to put this in, I haven't yet. I'll put this in the Google Classroom that you can hand in. Okay? A lot of you have not done 1.6 yet. I graded about 10 of yours. In Google Classroom, it's worth 100 points. It's not worth 100, but it is worth 20. Okay, so 1.6 is where you had to define engineering, pick what grand challenge was yours, what grand challenge was facing this world that you felt like your engineering design or your engineering field would be able to help, or what you would do. So, be able to see that, see what you need to do on 1.6, and then this. Next class period, which is Thursday, right? Not tomorrow. All right?
Yeah.
Yeah. We are going to have a test review. The test will be on Monday. No, it won't, because we don't have school on Friday. The test will be a week from today. Pardon?
It's on Tuesday.
Yeah, it wasn't going to be on Monday. It was going to be, it'll be next Tuesday. So I usually do a test review, give you a day to ask questions, and then have the test. So the day to ask questions will be Monday. So, any questions on what is being asked of you? We're good? Okay. So, let's just do this. 1.6. What do I do in lab time? 1.6. Is it done? Yes or no? If so, go to 1.8 paper bridge. If that's done, teachme.org, 3D. Okay? So is this done? Check. No. Then work on that. Check. Then work on that. 1 point what? 1.8 is not in Google Classroom as of yet. I'm just going to put it paper bridge and then you can just send it in. Okay. If you have just your engineering notebook, I could also just grade that right there. Okay. So if you feel comfortable handing that in, I'll get that in the grade book hopefully today, and then you can have it back. So I'm going to collect them right here. Okay. Normally I'd have to put a tab on there or something, but it should be the only thing in your engineering notebook right now, so we should be fine. So. Yes. If there's some questions, if there's question like, if it's not in Infinite Campus, does that make sense? Is that, what do you call it where you get your it might have changed. Where do you go get your schedule? Infinite Campus. It's not in Infinite Campus. It's not official, okay? I might look at something in Google Classroom, grade it or check it off or whatever. I might not put the grade in that, okay? So don't worry about that if that's empty. But if it's not in Infinite Campus, you need to talk to me or email me or make sure that I get it in Infinite Campus. Does that make sense? Because that's where you get your grade. So that's what you want to check. Not Google Classroom. Google Classroom should have the class. So I'm going to make a, right now I'm going to end this. And I'm going to put 1.8 paper bridge in Google Classroom. And you can hand it in that way, or you can put them right there. You had,
I had to go.
Yep.
I had to go early.
yeah, go ahead.